Well, welcome to Earth Science, Part 3, Duke Kaboom, Canada's greatest stuntman. And I went to the garage and found the jar of ash. So this is ash from Mount St. Helens, which went off 40 years ago, right about 40 years ago, sometime around this week. Volcanic ash. It's not like fireplace ash. It's not like barbecue ash. It's rock. Really, really, really bad news if you're around when this is filling the atmosphere and you breathe this in. Not only if you're right on the volcano, it's outrageously hot, and even if you're far from it, you can't breathe this stuff in and make it too long. It's like a mega, 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 mega fine dust, but it's rock. It's not just ash. I mean, it turns. I'm going to close this real quick. If it mixes with water, like in your lungs, it just makes like a cement. If it falls on a rooftop, it doesn't take much, a couple centimeters, especially with the rain, and that roof's going to be coming down. So, anyway. Alright, trickier question here. What we're looking at is an earthquake epicenter is here, and here's some places where they're going to be detecting those waves. And this all goes back to the concept that I wanted to practice with this chart right here. So if you saw Monday's video where I was out in my street clacking those sticks together, or Tuesday's video where I talked about this reference table, this is the key idea here. Again, you guys aren't going to have to actually do the math, but conceptually have the idea that if you're geographically close to an earthquake, there's not as much time for the P and the S to separate, so they arrive close together. And the further you get, the more of a gap there's going to be between those two waves. And, you know, I related it to, I do a worksheet sometimes that's Porsche versus Saturn. Now, Porsche is a faster car, right? So it's going to go faster and faster and faster, cover distance in less time. This one goes slower and slower and slower, and the further they race, the bigger the gaps get between the two of them. That's all this question is going to be looking at. It looks confusing on the surface, but I wanted to make sure I got one in with that concept, and I'll be doing the same thing when it comes to test time. Let's not have the computer freak out again. All right, so here we go. If you're a seismologist, that's what you're looking at, is what is the gap between the P and the S. So conceptually, that's what we're doing here. Now, this one didn't have S-wave arrival, and that goes back to the thing that's been on this quiz multiple times, the fact that S-waves don't go through the outer core. So if the earthquake happened here, and those waves they bend and refract through the planet, but they can't go through that outer core. So location C is going to be the one that's it's going to be that one. And let's see, that alone maybe will get us there. Nope, that gets us down to choices 2 and 4. The other ones will be determined by how the spacing between those two. So since this one and this one, that has the smallest gap, seismograph 1 must be the closest location, which is location A. Hopefully that's enough info to get us there. Yep, that makes it look like we got choice 4. So the important bit, if you know, question or no question, whatever, the important bit is that the closer those are, the closer the earthquake is. This one's further because they had more geographic space. They had more distance to separate the faster wave from the slower wave. That's where we're going with that one. This goes back to that other reference table in the Earth's interior one. The interior of Earth between a depth of 5,200 and 6,300 kilometers is inferred to be composed mainly of what? So come on down here. Depth of 5,200 to 63, so we're talking basically the very center of the Earth, which is the inner core, which is made of iron and nickel. Choice 4, iron and nickel. All right, cool. San Andreas Fault. What best represents the motions of the San Andreas Fault? Don't memorize. There shouldn't be much memorized stuff on this test. But there's our San Andreas Fault. It's a transform fault. I didn't spend as much time talking about it. A transform plate boundary. But that's where one's trying to go that way, one's trying to go that way. They're slipping past each other. Only since it's the entire lithosphere trying to grind, it doesn't just slide easily. It sticks, and then it builds up, builds up, builds up, builds up, and then slips quickly and releases energy, called an earthquake. If you saw that video with the earthquake monitor, lots and lots and lots of them. They're happening daily on a small scale. So this is just pick out which block diagram looks best. And it's number 4. 2 plates sliding past each other. This one is total nonsense. This one's convergent, this one's divergent. Down here, this hopefully is just another symmetry question. Oh, no, it's not, but it's a good one. So the most recently formed bedrock at a mid-ocean ridge, there's brand new rock. Somewhere on the mid-ocean ridge, there's brand new rock forming today. And then they spread and they spread and they spread and they spread symmetrically. So your newest rock will be right at C. Your oldest rock will be right at A. And then the Atlantic Ocean is kind of the easiest place to look at this. So brand new rock is forming on that somewhere today. The oldest rock is symmetrically on either side of the ocean basin. Along the coastlines is the oldest ocean floor, and it's in the ballpark of 200 million years old. All right, what do we got? Which part of the seismogram is used to find the distance and epicenter? Again, conceptually, this. Mathematically, no, you don't have to do it. You're lucked out. But conceptually, what do we need to figure out that distance? And it's the gap from P to S. So P wave arrival time doesn't really matter. S wave arrival time doesn't really matter. Difference in the arrival time between P and S, that is it. Difference in the height doesn't really matter. That has to do with the intensity of the earthquake. All right, that looks like it's it. Keep it up, guys. We're coming close. We'll do that test Thursday, Friday. Say hi to the gang. If you have any questions, let's do it ahead of time. Hope you're doing well. We're almost there. Keep it up, folks. We'll talk to you soon.